Okay, so in this next lesson, we are going to start talking about solving systems of equations. And we're going to do so by using the graphing method. So let's just talk briefly about what a system of equations is. A system of equations are two or more equations with two or more variables. So the ones we're going to concentrate on today will be two variable systems, which are also called linear systems of equations. They are linear because they are in the form of a line. They draw and make a straight line. So these are called linear systems. Also, you'll notice that they have an x and a y, much like linear equations do, or exactly like linear equations do. So we'll have two variables, they'll be x and y, and we're going to solve them by graphing. Now, the solution to a system, a linear system, is an ordered pair. So it's a point, an x and a y coordinate. So to find out how to get a solution to a system of linear equations, today we're simply going to just graph the two lines on the same graph, and the place where the two lines intersect, where they meet at a point, that ordered pair where they meet will be our solution. So basically, all you have to do is graph two lines on the same coordinate axis, and then the point where they meet, where they cross each other, is your solution. So this is why we did our practice lesson in the previous lesson. Was to just get us ready to remember how to graph lines. So we practiced slope-intercept form in the last lesson. And so number one, you see that I have two linear equations. Y equals x plus 6 and 2x plus y equals -3. So what we want to do is we want to graph the equations one at a time. So I want to do everything for the first equation and get it graphed on my graph before I do anything to the second equation. So I'm looking at that first equation, y equals x plus 6. And we notice that that one is in slope-intercept form. Remember that slope-intercept form looks like y equals mx plus b. So there's really not much we can do with that one except go ahead and graph it. So our b term is 6. So that's our y-intercept. So we're going to start at 0, 6. My slope in front of that x is an understood 1. And remember, for slopes, we need a rise over run. So my slope is 1 over 1. So I'm going to go to my graph. And so my y-intercept is at 0, 6. So I count up to 6 on the y-axis and put a point. 1, 2, 3, 4, 5, 6. And then I'm going to do my slope, which is up. Whoops. Sorry, y'all. I'm going to go up 1 to the right 1. Now, since I don't know where these two lines are going to intersect, and I'm drawing more than one line on here, I need to be very, very accurate and precise with my graph. So I want to do the slope more than one time. I know usually in class I only make you do your slope one time, but this is the one example where I'm going to need you to do your slope multiple times. So I'm just going to keep on going, up 1 to the right 1. Up 1 to the right 1. So I'm just repeating my slope over and over until I run out of room. So after I've run out of room, the lines could intersect back here in quadrant 3 and quadrant 4. So I'm going to keep going in the other direction. Down 1, left 1, down 1, left 1. So I'm still on the same line. I'm just doing my rise and my run both in opposite directions to make my line nice and long so I can accurately tell where the two lines will intersect. So I am going to try to, if my touch screen will let me put my ruler up here, draw a line as straight as I possibly can. And I kind of got off here, so I'm going to try one more time. Y'all know, y'all see me in class, y'all know I'm not very good at drawing straight lines. A little better. Oh, my touch screen has been touchy. All right, so there's the first graph. I'm going to try to swap colors just to see if y'all can see a little bit better. I know if I was in the classroom, y'all can see me point to the screen, so it's a little bit easier then. But we're just doing the best we can. All right, so my second equation says 2x plus y equals -3. And if you notice, that does not look like y equals mx plus b. So my first job is to get it in slope-intercept form. So I'm going to subtract that 2x on both sides. And then I have y equals -2x minus 3. Well, now it's in slope-intercept form. Good. My y is by itself, and that's how you know. So my y-intercept is the point 0, -3, and my slope is -2/1. So I start down here at 0, -3 on the y-axis. Always have your first point on the y-axis. And my slope says -2, right 1. So down 2 to the right 1. I'm going to do that a few times that way. But I notice they're probably not going to intersect that way. They're probably going to intersect up and to the left. So I'm going to go backwards. Up 2, left 1, up 2, left 1. Just make sure you're continuing on your line. And it looks like right there, I have 2 points on top of each other. So it looks like right there is where my lines are crossing. So after you see where they're going to cross, you can go ahead and draw your line. You don't have to do 50 bazillion of them. Okay, so there's my 2 lines. And to finish, you have to write the ordered pair where both lines intersect. Well, I'm going to make a big fat point. My lines are intersecting right there where that red line and that blue line come together. And that is the ordered pair -3, +3. So my solution is the ordered pair -3, +3. So your solution is the ordered pair where the 2 lines cross each other. Okay, so just as a synopsis of what we just did, get your equation in slope-intercept form if it's not already. Graph your line, do your slope multiple times, and after you've done both lines, you write down the ordered pair where the 2 lines cross. These 2 lines cross. The solution was at -3, +3. All right, let's see some more examples. All right, number 2. I got a linear system of equations here with 2 equations, same 2 variables. And so what I want to do is I want to focus on that first equation first. I'm going to draw a box around my originals so I don't get my originals and my work confused. And I'm going to take that first equation, and I notice that it is not in slope-intercept form. So I'm going to work on that. So first thing I want to do is get my first equation in slope-intercept form. So I can subtract 2x on both sides, and that gets me -3y equals -2x minus 12. And then I divide everything by -3 to get the y by itself. And then I simplify. Y equals a positive 2/3 x, because a negative divided by a negative is a positive. Same thing over here. -12 divided by -3 is +4. So now that one is in slope-intercept form. My y-intercept is 0, 4 on the y-axis, and my slope is +2/3. So I start with this graph. I'm going to go ahead and graph this one before I do the second one. To me, it's just easier if you do everything for the first equation before you even bother with putting the second one in slope-intercept form. So I've seen people get confused trying to go back and forth between different equations. So do every single thing, including the graphing for the first one, before you do anything on the second one. That's my teacherly advice to you guys. So 0, 4 is my y-intercept. So put your point there. That slope is 2/3. So I'm going to go up 2 spaces, to the right 3 spaces. So up 2, right 3. We're going to keep on going a few times. All right, all your dots should line up in a row. And then I'm going to go backwards a few times. Down 2, left 3. Down 2, left 3. Down 2, left 3. And I'm going to double check, make sure my points are all in a straight line. My touch screen's going crazy again. It doesn't like me trying to use a ruler on here. So I apologize if your screen's jumping. Miss Isabel cannot draw straight lines, even with a ruler. Y'all know it's like my enemy. Okay, so there's a semi-straight line. The dots help. There's my semi-straight line for the first equation. All right, I'm going to swap pens here. Use red. And my second equation is x plus y equals 9. So now that I've graphed and done everything for my first equation, I can work on the second equation for a second. So first thing I want to do is make it look like y equals mx plus b. So all I have to do on this one to do that is subtract my x. So y equals -x plus 9. Now, we know that negative x means that the slope is a -1. It's -1x. So that might help. So our y-intercept is the point 0, 0.09. My slope is -1. And I'm going to put -1 over 1 because it's a whole number. So 0, 9, and I think this is a 10 by 10 grid. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So there's 0, 9 on the y-axis. And my slope is down 1 to the right 1. So down 1, right 1, down 1, right 1, down 1, right 1. Nope, they're crossing. Down 1, right 1, down 1, right 1. So you don't have to do as many on the second line once you see where they're going to intersect. Just enough to help you keep your line straight. And again, my ruler's giving me a fit on my touch screen, so I apologize. And I can see that they're intersecting right here at this point right here. I'm going to make it fat so we can see it. So that big red dot is where my two lines crossed each other, and I'm going to count the ordered pairs. It looks like it's to the right 3 and up 1, 2, 3, 4, 5, 6. So it looks like the solution to this system is the point 3, 6. So remember to write down your ordered pair for your solution when you finish. Okay, because that's the whole point, is getting the answer. And the point 3, 6 is the answer. It's the point where the two lines intersect each other. All right, there's a few little special cases that can happen when you are doing a system of equations. So we're going to see that in this last example. And I'm going to tell you about the other thing that can happen. So here's our last example. It's a system of linear equations. I got two linear equations here. The first one is y equals x plus 4. And thank goodness that one is already in slope-intercept form for us. So 0, 4 is our y-intercept. And there's an understood 1 in front of that x. So my slope is 1 over 1. So I go to 0, 4 on the y-axis. And I go up 1 to the right 1 multiple times because, again, I don't know where they're intersecting at. So I want to make sure that my first line especially is very accurate. Like I said, I can go a little faster with the second line once I see when they're going to cross. But the first line, since we don't know what the second line is going to do, we want to do the slope multiple times. All right, I'm going to try to use my ruler here. It does not like it when I do this. All right, something like that. So there's my first line. So I'm going to get my blue pen and do my second line. X minus y equals 1. Well, that one is not in slope-intercept form yet. So I'm going to subtract x, and that leaves me with negative y equals negative. Go ahead and put a 1x plus 1. And then I divide by negative 1 on all of my terms and simplify. Y equals, well, that makes a positive 1x minus 1. So my y-intercept is 0, negative 1, and my slope is 1. So I'm going to say it's 1 over 1. So 0, negative 1 on the y-axis. And I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, multiple times. And I don't think they're crossing that direction. I'm sorry. My touch screen is super. And it just completely deleted all that. Here we go again. 0, negative 1, m equals 1 over 1. Sorry about that. I don't know what happened there. Technical difficulties. Maybe I won't do it again. So again, we see we're not crossing in that direction. So I'm going to go in the other direction. What in the heck? I really don't know what's going on. It just doesn't like that problem. Okay. Try not to use my... Anyway, it's not crossing in that direction. And if I go backwards, it's not crossing in that direction either. So I'm just going to go ahead and graph the line. And I notice, hopefully it'll let me, that I'm actually going to have here two lines that are parallel to each other. It deleted a ton of stuff here. I'm so sorry, y'all. I do not know what's happening. So if I notice I have two parallel lines, and what do we know about two parallel lines is they never cross each other. And so two lines that never intersect are not going to have a solution to this system of equations. Okay, because remember our solution is where the two lines cross, and parallel lines are never going to cross each other. Now, the way we could check to make sure they're supposed to be parallel is by looking at the slopes. Look, this slope was 1, which we said 1 over 1. This slope was also 1. Okay, so we have learned previously that parallel lines have the same slope. So these are indeed mathematically parallel lines. They're never going to cross each other. Therefore, the solution is that there is no solution. So make sure before you say that there is no solution, make sure that your slopes are in fact the exact same slope. Because if the slopes are not the same, they're not supposed to be parallel. Okay, so make sure you have the same slope before you say no solution. Something that could happen is you could end up with the same line after you put them in slope-intercept form. So, for example, if you have one that said, when you put it in slope-intercept form, and then you put the other one in slope-intercept form, and you got the exact same line, which is the same slope and the same y-intercept, then you would say there are infinitely many solutions. Because when you graph those two lines, they'll be the same line on top of each other. Okay, so if you end up getting the same lines, which I don't think you're going to do on your 4 problems on your practice, then you would say infinitely many solutions. So I'm just showing you that in case you do run across that in the future. All right, so now you have the information to work on worksheet number 4 and do problems 1 through 4. There are more problems on that worksheet that we will come to when we get to substitution and elimination. So after we finished all of the ways to solve a system, then you can go back and do problems after number 4. But if you want to now, go ahead and do problems 1 through 4. You have all the information to do that. So thanks. Hope you enjoyed. Have a good day.